Good day, friends. Welcome to Smart Book Guide. In today's video, we are going to be solving another example problem on Coulomb's law. The question says, the current which is flowing in a car's tail, right? The car's tail light is 2.8 amps, meaning that there is a current of what? 2.8 amp, which is flowing what? In the car's tail light. That's the light behind what? That is at the back of a car. So the current flowing is what? 2.8 amps. Now, first part of the question asks us to find how much charge passes through the bulb filament each hour. So we are asked to find Q, right? In each hour. So which means the time is what? 1 hour. What do we need to do here? We know that in order to find Q, there's a relationship between current, time, and charge. And the relationship is here. I equal to the charge over time. Definitely, to get Q, we need to make Q subject formula by cross multiplying. So I times T. All we just need to do is to substitute for the value, right? So what we need to do here is Q equals 2.8 times 1 hour. But you know that we can't just solve for 1 hour that way, right? So we need to say that since an hour equals 3600 seconds, therefore Q equals 2.8 times 3600, which equals 1.0 times 10 to the power of 4 coulomb. That's the charge, right? So for the second part of the problem, which says how many electrons pass through the bulb filament, right, each hour. In this case, the number of electrons that have to pass through the what? Casting light. That's what we are looking for. So in order to solve for that, we need to say the second part, right? Since in an electron, right, the charge that is on an electron is 1.6 times 10 to the power of negative 19. This one is what? Constant. We know that, right? So to know the number of electrons that have to pass through the current of 2.8 amps, which we calculated above, is that since we can just call this Q as Q constant, while the Q we calculated is Q calculated, and it is equal to 1.0 times 10 to the power of 4 coulomb. In order to know the amount of electrons that have to flow through the car tail light, what we need to do is that N is the ratio of what? Q calculated divided by Q constant, right? Which equals 1.0 times 10 to the power of 4 coulomb, all divided by 1.6 times 10 to the power of negative 19, right? Therefore, N equals to 6.3 times 10 to the power of 22, meaning that the number of electrons that has to pass through the car tail light is what? 6.3 times 10 to the power of 22 in an hour, or 3600 seconds. I hope the concept about these questions is demystified. If there's any question, feel free to ask in the comment section. Goodbye.